Live from the internet, it's the Localhost podcast with Mark Drew and Rob Dudley.
Hello from the internet. Welcome to the Localhost podcast, Develop Branch. This edition of the podcast is where we can add features in the safety of our local development environment. We branch from the main show to bring you features such as interviews or more in-depth discussions. I am Mark Drew, and joining me in this special edition of the podcast is Rob Dudley. Let's get on with the show. How many puns about Git are we going to do in this show? Shall we commit not to push the point and make sure we don't pull our guest in too many directions? Rob, in our Master Branch episode on Docker, we received a number of merge requests. One of them was by Geoff Bowers. So I'd like to welcome to the show Geoff Bowers.
Hello there.
So who is Geoff Bowers? Geoff Bowers runs a great development agency called Daemon Internet Consultants in sunny Sydney, Australia, and has been involved in the world of web development longer than I can remember. He has run conferences such as WebDU and is a powerhouse with a long history of successful web projects, including the Australian Olympics Commission and Far Cry CMS. Geoff, would you mind giving us a potted history of your background? Was that accurate enough? Did I miss anything out?
Oh, fantastic accolades. Yes, wonderful. I guess that's me. I've been a little bit of a sort of a varied history. I was grew up here in Australia, went to school in Scotland, of all places, went to university in England, biochemistry, became a derivatives dealer, and then in the heady days of 1995, I set up Daemon Internet Consultants to build bespoke web applications, and been doing that for the last 2 decades, hopefully with a little bit more finesse these days.
Awesome stuff. You were kind to come onto the show and clarify some of the points we made in the main branch of the episode 001 if you're following at home. And we'd like to delve deeper into how you're using Docker and how it's working out for you.
We were very early adopters of Docker, so we've been running Docker in production probably for more than 18 months now, and we've nearly gone through the process of converting all of our major applications that are under any sort of operational support or development across to a Docker environment. So yeah, we've had quite a bit of experience with it. There's been some considerable pain along the way, and I think it's worth it though. It's certainly the future of applications, solution architecture, and the like. I think it's hard, and it's the sort of thing I hear in the podcast, the original podcast. It's hard to define why use Docker. You know, what's the kind of driving force for moving to Docker? And we do quite a bit of consulting in that area now in terms of trying to enable teams to move to development pipelines that use Docker. And it's still the kind of most significant question, at least from a management and strategic level, as to why make that investment to move to Docker. And it's hard, I guess, to understand if you're looking at a single kind of server environment or a single kind of test environment that you might be using to kick the tires, to get the kind of full grasp of why Docker.
Right. I think it's trying to explain to people the idea of like putting your application into containers, and not just Docker, but just being able to split out your application and why you'd split it out. I mean, there's always been a mystique around clustering, for example, and putting something, being able to split out your application so it can be clustered is the first step, isn't it?
Yeah, for sure. I mean, I think one of the things I often do is look at kind of an anecdotal history of what we did to get to our Dockerized environment. So at the moment, at any one point in time, we probably run about 20 different active code bases, whether that's under active development or under some kind of ongoing operational maintenance and support. And nearly all of those now follow through a continuous deployment pipeline that leverages the Docker environment or the Docker ecosystem in general. And I think we didn't start with Docker, obviously, and we wanted to have that aspiration of being in a kind of continuous deployment environment long before Docker came on the scene. But I think the best way of describing these sorts of environments, the kind of classic aspirational environment like Netflix or GitHub or any of the large kind of engineering teams out there that have these beautiful and resilient continuous deployment pipelines where they can have an employee deploy something to production on day one. And I think the reality is for most development teams, not even just small teams, but well-financed teams, is it's pretty much an impossible kind of pipe dream. I mean, it's something that you want to do, but it's extremely hard to get to that particular point. And I think people underestimate just how intimate a code progression or a code pipeline really is. And by intimate, I mean the process by which you make a change and that gets migrated through whatever testing regime you have and then deployed out to a production environment. To automate that process takes a particular set of skills, like the guy from Taken, that you need to implement, and they're rare skills, and often you don't have the luxury of being able to just kind of tool around until you get something right, especially if you're breaking everything as you go in terms of the normal quality assurance that you might be doing in your business. So, I mean, if you like, I'm happy to kind of go through how we got to this particular point and the kind of trials and tribulations we went through. I think it's often good to sort of understand the historical background of why Docker has kind of emerged as an ecosystem and the pain points that it addresses in general across that overall development pipeline.
I think that'd be great. I think the audience would like to see how you've gotten to the stage that you're at, because it is very difficult to explain why Docker without knowing the pain points that it's is there to alleviate, so to speak.
I think we all, I mean, certainly back in the 90s, you would have started with a server sitting under a desk somewhere with a kind of huge mess of cables sort of floating around in it. We had our own hosting internally on a 128K ISDN connection and managed everything ourselves, all the hardware, the network connectivity. It was, it was kind of the Wild West in those days. And because of the way in which you purchased infrastructure and just the literal kind of, not just the cost of it, but the cost of being able to sort of provision, house, and have it physically located somewhere, you kind of drifted towards a monolithic sort of architecture where you had, you would tend towards a larger server with lots of processes running on that particular server. And so I think historically we used to look at things called a kind of Dragon Slayer document, which would detail exactly how a particular server had been built and configured. But really over time, any sort of period of time, any volatility in a development team in terms of change of staff and the like, you typically end up with one of these monolithic servers that works, but you kind of have no idea how you got to that particular point, and everybody's kind of terrified of making a change or terrified of doing a system update because it might perturb the balance that you have kind of managed to put in place to have everything working. And so it becomes, in the old classic terms, a bit like a pet. So you've got these pets in the server room, and you have to constantly keep mollycoddling them the whole time. Whereas in kind of more modern infrastructure terms, you're looking at trying to treat
and they have interesting names that either are
give them names.
Yeah. You put stickers on them so you know which one is which, etc., etc. Become very important to your life.
That's right. They have a personality and they're precocious and all the rest of it. And so you want to kind of progress towards that that ideal of having servers treated like cattle, where effectively you're farming them the whole time. So if you want to do an update, there should be no reason why you shouldn't just build the server from scratch. You shouldn't have any fear about the ability to kind of completely redeploy the server without any issue whatsoever. And that in a kind of, when you have just a couple of physical servers, is a very difficult place to be. It was a very expensive place to be. And so you had to be in a very kind of large organization, have the will to do those sorts of things. And it's only relatively recently, in the last sort of, I guess, 5 to 7 years, where infrastructure as a service has come to a point where you can really just dial up servers on demand. You no longer have to commission a server and wait 2 to 4 weeks for it to be deployed and implemented. You really just ask for it and it's there in 10 minutes. So it really, quite a few years ago now, I guess probably around about sort of 7 years ago, we were looking at fully scripting servers, getting a server from the ground up being built. And the notion for us was that these individual servers, the script that programmatically built that server would act as a documentation for that server. And so it would give us a much more robust quality assurance about how the server was built and much more confidence about how we might upgrade the servers and how we might maintain those servers. And to get into that area, and again, I could go on for hours about that. That's all old history. You don't do that these days. But we had Vagrant. That was our kind of original starting point, and that would sit on your desktop. You would script that environment. I decided in one of my most woeful decisions to learn Ruby by programming chef cookbooks and recipes. That is not the way to learn Ruby. But in essence, Chef is like a kind of a special scripting language for programmatically building servers and installing things. So we went down that path and had a quite kind of robust development environment, which would also replicate the production environment. And you could walk in as a new kind of person to a project, and it would take 20 to 30 minutes, let's say, for your development environment to configure itself while you had a cup of coffee. And the similar thing was true in the server environment. And that becomes more sophisticated. We moved from Chef to Ansible and a lot of shell scripts and that kind of Swiss Army knives that you have in a kind of Linux style environment. And then moved to AWS, everything in AWS programmatically built, and we used OpsWorks for producing OpsWorks is like Chef as a service. It's still a popular environment inside AWS for providing a kind of DevOps strategy or framework for the deployment of larger scale applications. And so again, Chef, implement things, have them built. But the problem with that is it still takes a very long time to bring up a server. So if you want to bring up a server, it's still kind of monolithic. You can break things up into layers, different sets of servers. It sounds very expensive, and it is. You've got sets of servers. If you've got multiple availability zones and the like, you need to have a lot of servers in place. And the best we could do, the absolute best we could do, was to deploy something into a cluster in 30 minutes. So we'd be pulling an AMI snapshot, and then we'd be updating that with the latest code base, and then that would eventually drop into the cluster, a couple of health checks, and it would arrive. So a long period of time. And trying to write those scripts is also extremely time consuming. So if you write a script that builds a server and it takes 30 minutes and you screw something up at the 25-minute mark, you kind of have to start all over again. And it's a really torturous kind of environment to be in. Nothing's really quite versioned except for the scripts. So the servers themselves have to be kind of built from scratch the whole time. Still pretty good, not bad. But the reason why, the first reason I think why Docker is so appealing to people who have kind of moved down that particular environment, and I'm really talking at this stage about the kind of bigger end of town where you have a more complex application and you want to do these sorts of things, Docker makes life a hell of a lot easier because the way in which it articulates that scripted environment in its kind of layer structure, without getting into too much detail about exactly how Docker works, but in simplified terms, you can have a series of stop points, which are kind of preset or pre-baked versions of your built server or your scripted server. So in the case of, say, an image that we manage for the Docker community is the Lucy image, which is a JVM scripting language that runs on pretty much any servlet container. We use the kind of an Ubuntu base, and that's snapshotted, and then that's got an open Java stuck on top of that, and then on top of that is the official image for Tomcat, and then finally our deployment of the scripting environment. So it means that every time we make a change, we're only making a change to our component. All the other pieces, the Tomcat, the Ubuntu, the Java implementation, any kind of standard set of scripts that form part of that particular base image are pre-built, pre-done. We never have to go through them again, and they're kind of instantly available to us. It gives us the ability to effectively version control the infrastructure. So if we do an update, we can very quickly roll out that update. It's only a very simple differential change rather than a complete server, scripted from scratch. And we can roll back very quickly. If something's wrong, we just roll backwards and forwards. And when you think about production environments rolling backwards and forwards, you're still doing exactly that when you've got development environments and QA environments or any type of continuous integration environment. Every single minute kind of counts when you're looking at doing those builds and producing service. So it massively improves the performance of your ability to actually deploy what, for all intents and purposes, looks like a full-fledged server. It's not really quite that. It's not quite a virtual machine, but it's very similar to that. So version control. So this version control, sorry, if you've got any questions, just leap in there.
I'm just going to dive in with one because you picked up on a point that I actually find really interesting. Not something that I've actually come across, been bitten by yet. But given the layered nature and effectively the fact that you're reliant on the maintainers of these upstream Docker images to maintain your own Docker image, have you run into situations where actually you've had problems that have been introduced as a result of changes to upstream? I mean, how does that affect you in terms of the compatibility life cycle? There's a lot of moving parts here, and you only control the very last step in the process.
Yep, sure. I mean, it's not the same sort of desperate environment that you see in a kind of Ruby Gems environment or, say, Node.js, where you effectively can download a library and then all of a sudden you've got this massive kind of cascade of dependencies where anything could potentially cause some sort of a disruption as you compile your app. So it's not quite as bad as that. You're looking at probably only a few layers. You can obviously independently test those layers if you want to, but the reality is if you're maintaining a proper base image that's going into production, you should be on a fixed version of that particular image so that you don't get any surprises. You could, if you wanted to, nominate the kind of meta label of latest. And whenever you do a build, you always look for the latest underlying base image, which would be a little bit dangerous. And we might run that in a
That's kind of the default, though, environment. Isn't it?
It might be out of the box in the Docker demos, but I don't know anyone who's serious about a production environment that would run latest as the base image unless they're the people writing the base image.
Okay, so just to quickly summarize then, what you're saying is effectively treat it as you would any other package management service where for your production deployments, you want to make sure you've pinned your dependencies to a set version, and then effectively you can test any changes upstream as and when you do a new release, right?
Absolutely. And so, and that worked quite well. I mean, for example, the Lucy thing, we fixed that on a specific Tomcat base image. We used to build our own image from scratch. Sometimes we do that every now and again just to make sure that the official image is, there's nothing particularly wrong with it. But one of the advantages is if you can actually trust the source of that image, and the Tomcat official image is fairly well trusted, then it does away with the need for you to have to go through the process of doing all of your own QA for that particular image. We typically accept that if the Tomcat base image for a specific version has been released, that it's been relatively well tested, and so that we can rely upon it to work at least at the level of Tomcat. And then we put our own stuff on and test from that point onwards. You don't have to, though. You absolutely don't have to. And one of the beautiful things about the Docker environment is you can very quickly have a look at what makes up the specific layers of any base image and then just build it yourself directly. It's more time consuming to do that. And it's obviously a little bit of extra organizational work to maintain that. But it's not a difficult thing to do at all. I like the standards there because if Tomcat improve, their particular environment, or they improve the performance of the way in which they have their initial setup and so on, then we get to benefit from that. But obviously, some communities, the generic installation is just too generic, and you want to optimize it a little bit for your specific environment. And I think the Tomcat's a good example because one of the things that we're looking at doing is changing the base Linux to an Alpine Linux, which is a much kind of lighter weight base.
This is stripped right back,
system.
isn't it, over, say, a standard Ubuntu?
Yeah. So we were going to go through all the trouble of testing a particular Tomcat on Alpine, and lo and behold, at the end of last year, Tomcat released an official Alpine image. So we'll be releasing this, probably fairly shortly, a Lucy version of an Alpine image that's based on that. We'll have two offerings. You can either just be straight up Tomcat or Tomcat on Alpine. So, those sorts of things, I think it's a really good example of being able to leverage that community and take advantage of other people's work in that area. But the layer stuff is great. Really does make life much more interesting when you can version the infrastructure that you've got.
It's following on from that point, I've actually extended the Lucy Docker image because I wanted to use MongoDB and have it pre-installed, for example, pre-configured. Not pre-configured, more pre-installed, because you don't want to have a specially configured image. But it comes in very, very handy to be able to just say, use Lucy, and now I'm going to add another thing to it. Now I'm going to push that to Docker. Other people can use it. I noticed the other day that there was quite a few pools on that image, and people seem to be using it.
Yeah, I think it's a great idea. One of the things that we do very often, there's all sorts of discussion about whether or not you should have a single process within the container, and that's it. So by design, in theory, you should just have a single process running on that specific container. And if you need multiple processes running, like a series of microservices that might be running together in concert, that they should each be their own individual container. So, for example, you might have a web server like Nginx that sits separate to your Tomcat installation, and the two of them are bound together via whatever networking protocol that you might have, but in essence, they're completely separate containers. We do that so often that we decided that we would produce a compound image, which was effectively Nginx and Tomcat running on exactly the same image. That's for a variety of reasons, that's something that works well for us. And so we also maintain that as an alternative base image. So you can have just the standard Lucy image that sits on top of a Tomcat, or alternatively, you can have what we call a compound container, which effectively has both Nginx and Tomcat running simultaneously, which is also cool. So another one of these kind of options. But you always should extend the base image. In the case of Lucy, that is an absolute must, because at the very least, you would be copying your project code into that particular environment. And so you're always going to have your own Docker file that has at least one line that says, come from the base image from Lucy. You could always have another line that says copy your code from here to here, and then whatever configuration options, whatever additional extensions you want to install, all that sort of stuff.
I think it's interesting because there's two kind of use cases here. There's one in which you're providing a product or service, such as Lucy as an example, or we can look at Nginx as another thing, or MongoDB or MariaDB as an empty container, right, with the service running, so you can just fill it with whatever you like. But you also can create your own containers, which are your application. So we're doing this, which is where we wrap up a version of our application, and we then store it in a private repo, and then that gets deployed into our infrastructure.
There are all kinds of strategies for this. I look at it as, and I don't know if it's common terminology or not, but this is what we use internally, is we look at containers that, or Docker images that have batteries included, and those that come without batteries included. So, if for want of a better term, so something like a MySQL container, it is batteries included. You really don't need to do anything at all. You just spin up the MySQL container, and you just need to provision it with a location that is going to hold your data, kind of a durable location for that data, the file system, for example. But in the case of something like a Lucy or a Tomcat container, it doesn't do anything. Sure, it might respond to an HTTP request, but you need to actually deploy an application into that container for it to function. And so the kind of batteries are not included, and you need to, at the very least, include your code that runs within that particular environment. And so you're always going to have a Docker file that sits within the context of your Git repo. So we actually publish a standard project structure for Lucy, and that's the project structure we use incidentally for all types of projects, whether they're Python, PHP, or Go apps. We use exactly the same kind of structure where we have a Git repo, and at the root we have a Docker file and any other sort of configuration files, what we call stack files or application configuration files for their orchestration when they get deployed into production, and a series of subfolders that contain the code bases and modules or whatever it might be. But yeah, absolutely, you want to be able to have a Git repo that you can pull and have built by anything, built locally, built by a build farm or whatever. I'm probably getting a little bit ahead of myself. I had a couple of notes that I wanted to kind of cover. Like one of the things, getting back to the kind of story of why Docker, I think there is, now that we have this ability to get away from having these kind of monolithic servers, there's a natural progression towards people moving to a more microservices architecture. So whereas in the past you might have plugged everything into one server because it was pragmatic and convenient, now you kind of naturally find yourself breaking things out. Even if you have a kind of old school application approach, you probably have your SMTP server somewhere, or you might be using an SMTP service. And there's a variety of, a heap of commodity services, whether it's for image manipulation or log management or error trapping or whatever it might be. So you now, even with an old school application, tend towards having a combination of things where you have your unique, tailor-made or bespoke application and a series of commodity services which are gradually being decoupled from your single physical server. So there's a kind of a natural trend towards that. When you move to containers, one of the biggest issues is actually trying to divide your application up into all of those individual processes or microservices. And so, it is a real problem. This whole notion of having a microservices architecture for somebody who has a legacy application typically means quite a bit of pain and work trying to get to that particular point. You can kind of cheat a little bit by having, a container that wraps up what looks like effectively a monolithic service initially and gradually eat away and take services from that. So the next key component that the Docker ecosystem offers you is a very easy, incredibly powerful solution for composing or providing a composition of microservices that work together as a single application. So there's Localhost, where your containers will run, and there's also a thing called Docker Compose, which will configure that environment in a specific composition of microservices. So your app, and typically an app that we might run would have a Lucy container, a Memcache container, it might have a RabbitMQ container, and it might have a MySQL container, at least in its test environment. And all of those things need to be present and running in order for your application to actually spin up. And so you have a single file that defines all of those things. And in a normal environment, when I say normal, a non-Dockerized environment, you then have to worry about, is the network setting right? Can my application server talk to the database? Can it talk to Memcache? Are they secured from the public network? Is it a little private network? All of that stuff is done in just a couple of lines of config within your Docker environment. I mean, it's a truly magnificent and kind of powerful mechanism to provide a composition for this kind of myriad of microservices that make up your specific application in the modern age. So composition of services, extremely, extremely easy.
Geoff, it's interesting that obviously we kind of touched on microservices there and the suitability, but also the more general process by which we can break up legacy applications. We're looking for these service boundaries, these edges that we can effectively use to start separating our legacy applications out. And even for larger legacy apps, as you're quite right, the pain of that process can be significant, but it is pretty much upfront and one-off, right? One thing that springs to my mind is that for any decent-sized application, we're probably going to end up with a whole bunch of different containers fulfilling different roles. We're going to need email, we're going to need log management, we're going to need potentially one or two different types of data storage, database, and caching and what have you. And, of course, our core application stack, which we may also be looking to start breaking up further. What kind of tooling would you look at to actually make the management of all of these disparate parts that make up the whole? Is there anything above and beyond Docker Compose or the standard Docker tools that you look at using? Or is it actually so simple that it's sufficient just to use the stuff that's out of the box?
So there's the first thing is the composition, this Docker Compose. If you imagine that puts together a specific association of containers that make up your application. You can nominate the number of containers that might be deployed and so on. But often we look at that from a development perspective. It's going to be a single server environment. When you start, it's going to be a single server environment. And you're constantly kind of looking at in the context of just spinning these things up in a single server. Once you go to a larger environment, so a node cluster or a whole group of individual servers into which you're deploying containers, you now need a separate set of tools to do what we call orchestration, to effectively deploy those containers across your kind of fleet of servers, if you like, that are out there. So a couple of things that I think are important as a run-on from composition of services is configuration by environment. And so very often one of the barriers to action in changing these sort of legacy applications is you want the same build everywhere. So if I have I build a Docker container, I build a Docker image and spin up a container, I want that to be exactly the same image used in development, as in QA, as in production, wherever I might be sending it. If that's the version of the image that I'm looking at, I should expect it to be the same everywhere. I wouldn't be compiling a specific version for dev and a specific version for QA. The way in which you would change the behavior of that container when it's, if you like, instantiated, is by passing in a whole series of environment variables or having the container itself look to its environment to configure. So that the configuration by environment is critical. And once you get a container that when it spins up, it kind of looks at the environment variables that it finds itself in, whether they're local to its physical environment that on the server that's on, or the environment variables that are being passed in when it was actually instantiated, and it should behave appropriately in that environment. You can then take the next step of saying, okay, well, I'm going to throw this container out into a whole sea of servers, and I want something to just go, yep, there's a little bit of space on server number 8. Let's plug the container in there and have it run. So this next level up is the kind of orchestration of services. And this is where you kind of get to the kind of awesomeness of Docker in a larger continuous deployment pipeline, because you're now moving from just saying, okay, I've got a local development environment and a whole series of random scripts, if you like, or tooling, which effectively put together a series of artifacts and roll them from one stage to the next along that deployment pipeline. And you now have a nice, discrete, wrapped up container where the edges of that container are standardized, well known, and can be applied to a series of generic tooling that you can either get from the open source community or from the commercial community. And there's quite a few of these options available to you. I'll get into that. Just to quickly sort of sidetrack on the continuous pipeline. Once you have that aspiration that you do want to have the ability to make a change locally and then very quickly deploy that out to a production environment, the biggest difficulty in that is all of the kind of strange vagaries of the differences between your environments, your development environment, your QA environment, whatever continuous integration or testing process you have, and then finally deploying it into the production environment. They're all, while they may look the same and the code and artifacts may be similar, they tend to be physically kind of different environments. And without having something like a Dockerized container to take away all the rough edges, take all the lumps out of it, it can be quite an arduous thing to develop in the first place and then to go on to maintain. So the only reason that as a small company with 20 different active applications that we can actually maintain continuous deployment pipelines is because on the surface and the outside, they're all effectively the same. They're all exactly the same pipeline. The internals of each of those applications are obviously quite different, but the pipeline's the same, whereas in the past it never was. We never had the time really to dedicate, especially to external clients, how you're going to maintain that. It's not like you've got the same application you're working on day in, day out. You're a SaaS solution or one of the kind of big engineering teams that have the luxury of being able to concentrate on that deployment pipeline. But now you can do that. And so the next step up, this orchestration set of tools, and there are things like Mesos Marathon, which is a platform that we work with as one of the more mature enterprise platforms in that particular space. There's Google's Kubernetes, which is another orchestration tool. tectonic from the people from CoreOS. Docker itself has its own, what do they call it, Docker Data Center or DDC that's now available. And Docker, I think, and one of the best places I think for people to start is Docker Cloud. Docker Cloud, this is Docker's SaaS solution. So they have a kind of a SaaS solution for orchestration tooling. Amazon has a solution, the Amazon Container Service, ECS. So there are all kinds of options. They're all slightly different. Another one I like that's very like Docker Cloud but open source is Rancher. And there are many others. So it's an extremely volatile area of the market at the moment. And the tooling changes in Docker have just been, I mean, nothing short of kind of meteoric in terms of the impact and speed of change and everything that's been happening over the last 12 months. So it's a bit hard to see where the dust will settle. But the good thing is that if you have a containerized application and you are using these kind of, these little black boxes that, as far as your deployment pipeline is concerned, that are containers as they travel down that pipeline, you should be able to quite easily change your tooling. And so you'll be looking at vendors out there that are competing for the quality of their service rather than a kind of vendor lock-in that you just can't get out of. And that's a very kind of cool factor of the kind of standardization of all of these interfaces. To give you an idea of the sort of thing that we would do, to give you a sense of it, we run the Australian Olympic Committee's public-facing infrastructure. So everything to do with the Australian Olympic team, we manage. And they have a kind of a order of magnitude increase in traffic demand during any sort of games period. So for the last Rio Games, London before that, Winter Olympics is it's got a kind of 100-fold increase, but it's not the same kind of impact, at least here in Australia, as the Summer Games. And so we have to have an architecture which we can go from, a couple of servers to say maybe 8 servers all running simultaneously just for a kind of a 2-week window. And so you need that capacity to scale the different layers within the infrastructure really easily and simply. And once you have a containerized environment and you're running just 2 containers, you have an app that will run across more than one container. You've got whatever session management that you need to handle your clustering. You've got a central file system for storage of assets, that type of thing. Once that's been done, even for just a very small implementation, scaling it from 2 containers to 200 containers would take me, if I was to just dial up the Office infrastructure today on Amazon AWS, providing AWS didn't run out of servers, probably take 20 minutes. So I mean, it's phenomenal. I mean, you would literally just go, I'm going to have all of these servers and I'm going to deploy X number of containers per server, and it would just sit there grinding through, deploying all of these things. And the only reason it take 20 minutes is because it can take up to 10 minutes to spin up a server in EC2. But the actual deployment of the container would take minutes. So incredibly powerful. And in terms of that environment, we actually run exactly the same container images local in a dev environment that is on Windows or Mac or Linux. So we have a kind of 30-30 split or thereabouts in the Office for those sort of operating systems. And then our staging environment is a direct replica of the production environment, and then the production environment itself. So all of these options are great. You can have some things automatically go out, so you make changes, somebody creates a feature branch, and automatically it's deployed to the staging environment for testing, or you can manage that so that it only goes out when you specifically select for it to go out. Once you get over that hurdle, that kind of barrier to action, then all of these things actually become extremely easy because the tooling's just there. You're pressing buttons and away they go. Docker Cloud is relatively simplistic. I think certainly if you've never been involved in those sorts of environments, if at first glance it's incredibly powerful. When you start to move up to the more enterprise scale, like the Mesos Marathon environments, you're looking at things that are very, very sophisticated. So the ability to periodically start containers up and shut them down and auto scale them and health check them before you bring them into the cluster. The ability to do blue-green deployments in an automated fashion, to do rolling sequential deployments, to do canary deployments where you only deploy, to a very small percentage of your audience to see whether that application is working. All of these things that are kind of the pipe dream of those engineering companies that you dream of kind of working for are possible. So, and at a very low cost. If you've got the skills to implement and you have that particular service in place, it's not like a moonshot where everything has to be right, and if anything's wrong, there's a kind of catastrophic failure. It's absolutely achievable. And I think that, for all intents and purposes, is why Docker has the aggressive uptake, in particular at the bigger end of town, because of all of these features are so much easier to get into. And then slowly but surely that'll start to filter down to the lower end of town with the kind of smaller shops, smaller single server implementations even, and the like, because the barrier to action will be less.
Fantastic. Rob, do you have a question?
I'm actually more or less done, to be honest. I think I was about to wade in and say, okay, so tell me, how do you scale Docker? But you just did. It's a really interesting observation that we're getting kind of this larger shop adoption first, as they effectively pave the way. And I think certainly I can see and very much throw my agreement behind this idea that it's gradually going to become the norm as we work our way down through the smaller, more boutique kind of development houses. If nothing else, as they realise that this process of paying down the technical debt to break up the monolith to get them into containerization and what have you does mean that they can be that much more agile. The other thing, just listening to what Geoff was saying there about the ability to spin up, is it does offer this final actual realization of the promise of the cloud, right? This idea that we can just spin resources up and down and what have you, and it's totally flexible, which, let's face it, unless you've actually got something like Docker or something managing your containerization of your applications, is actually a lie, because you still have the same problems with deployment and what have you that you've always had. You're just now running them in a different environment. One of the kind of very small point, just to finish up from my end anyway, how do you find that you've got Docker running on AWS and what have you for potentially really quite high load or high demand services? How does that compare to just having direct access to the metal, running this thing on tin, running your applications on a physical server?
So I think it's a good question, and I think the reality is that in all of these virtualized environments, the bare metal just crushes the kind of classic virtual machines performance. And Docker running on a bare metal machine is very fast. But typically, if you're in an infrastructure as a service style environment, it doesn't always have to be like this, but say we're talking about Amazon, a classic sort of Amazon compute unit is way, way, way slower than a kind of standard CPU on a physical machine these days. But having said that, they're very inexpensive, and if horizontal scaling is your issue, then you can very rapidly scale up. Your bare metal server might be the equivalent of 10 servers, but you can easily scale up 10 servers. Absolutely you can. And to give you a sense of how that works, if you're using, and this is not unique to Docker Cloud, so I would say that straight away. This is just happens to be a series of features that we use regularly. I think is great. I would go into Docker Cloud and I would set up a new node cluster. And effectively a node cluster, Docker doesn't really see it as a cluster of machines that you're deploying applications to. So we normally think of that in terms of some sort of code progression. If I'm deploying to a cluster, let's say there's 3 machines there, I need to update each machine individually, or I need to somehow update one machine and then replicate the changes across the cluster. There's all those kinds of classic old school clustering arrangements. Whereas the orchestration tools don't look at it like that. They see the node cluster as just one big computer resource. So it could have 3 servers in it, could have 30 servers in it. It doesn't matter, just sees it as a pool of resources. And as in a kind of an extension to Docker Compose file, a composition file, in Docker Cloud you have what's called a stack file, which is essentially exactly the same as a Compose file with additional metadata which you can nominate, which can be things like, I only want you to target servers that are tagged with this label. The label might be production, for example, or stage. And so you can very readily target the deployment of services onto specific node clusters if you want to. And it will automatically go, okay, I've got 3 servers. This is the least active server. I'll try and slot the container in to that particular server. But you might also give some additional instructions. You might say, no, it has to be in what we would call a high availability environment. And so if I'm going to deploy 2 containers, they must be on separate physical hardware, even though it looks at it as a kind of a universal computing resource, and it will automatically make that deployment. So to give you a sense of, in terms of our smaller clients, we have a heterogeneous Docker Cloud platform, which we offer as at a kind of a reduced hosting cost as a shared platform effectively, where these containers will be deployed into a kind of mixed node cluster of multiple clients. Much bigger clients typically have their own clusters. But the cool thing is we just go, yep, throw it in there, find some resources, and when we spin up that cluster, it will automatically distribute those nodes across the individual availability regions within AWS. There are 3 different data centers in the Sydney point of presence here in Australia. And so if I ask for 3 servers, I'll get one in center A, center B, and center C. That's automatic. When the containers are deployed, they automatically link up. They know where each other is. I mean, I don't even need to look to see what server they actually made themselves onto. They just slot into the easiest possible point. If I'm running out of resources, so you need to kind of maintain some kind of monitoring to decide, have I got enough memory, have I got enough CPU, etc., you can just spin up an additional server. You could automate that if you wanted to, like an auto-scaling group within AWS. But typically, you kind of know, what sort of environment you got. We normally try and run at about 70% capacity and leave a float of about 30% capacity on all servers at all times, in case we need to kind of move things around, swap things in and out. But think about that in terms of, say, the Olympics. We need to scale up for 2 weeks. We can use exactly the same environment. We just double the number of nodes, double the number of containers, and it automatically just spills to fill the space within that node cluster. But if I have a staging environment that I only need to use for half the time, we actually spin up a staging cluster from 8 a.m. till 8 p.m. each day, and it's shut down. So 50% of the time we don't pay for any compute resources at all from EC2, and there's just a script that literally says start the node. Well, the node's always there, the cluster's always there. It just says scale it up to 3 servers or 2 servers or whatever number it is, and deploy all of these services that are earmarked for staging or QA or whatever it might be.
I bet that can be a real kicker if you've decided you're going to work late just to get something finished off, and the staging environment, that's gone.
You can block it, obviously, but it does give you the shit. It does give you the shits when it turns off in the middle of everything. But it's fantastic if you think about the cost, because normally with the staging server, it goes through a furious amount of activity, and then it's just dead weight the whole time that it's there. And you can have quite complex environments that you're only using for very short periods of time, because you can do what I was saying there, that's automated, but we also have another environment that's called Skunkworks, which is effectively a kind of testing and labs environment where we will spin servers up to kind of try new things out. And most of the time that's just completely turned off. But it only takes less than 10 minutes to bring the entire infrastructure up in place and deploy all the applications. You start to look at that. So let's say there are 3 servers there, and the other thing is, before I get onto that, the choice of server. So Amazon offers a whole range of different services. Typically, web applications, and especially if we're running web applications that are, say, content managed stuff, and a lot of content might be hosted off CloudFront, some sort of proxy at the front, which is edge caching all that data. So we don't really need a great deal of CPU resources to run those applications. And so what we can do is have a specific node cluster, which is it's weighted towards a more memory-focused set of EC2 instances, like the M class or R class of EC2 instances. So we get much more memory compared to the CPU, and we can fit a lot more containers in there because we know that it's not going to be working hard, as compared to, say, an application that is a more a gruntier sort of reporting application, or something that does zipping or image manipulation or some kind of binary transfers on the actual server itself, you're going to end up with a much more CPU intensive set of requirements. So you can have a specific set of EC2 instances that are much more effective for that particular environment. And those things, again, are things that you can spin up and shut down. You're starting to look at the resources from, in our instance, AWS, but it could just as easily be Azure, or it could be DigitalOcean, or it could be one of these bare metal providers that provide infrastructure as a service for bare metal. There's an example of each of those actually supported directly in Docker Cloud and by most of the provisioning tooling in many of these orchestration tools, so that you're kind of treating it like one big computer. It's weird because you're going back to the days of having that monolithic computer sitting under the desk in the 90s where everything's bunged onto it, except now, rather than having a whole series of individual apps installed, you've got this nice collection of discretely maintained containers, each running their own little process, all individually scaled. If I need more application servers, I just spin up more containers in that particular tier of the microservices. And it really is a kind of much more granular way of treating your infrastructure. Kind of a beautiful environment. If I need to upgrade those services or upgrade the cluster, all I do to upgrade the cluster is I just nuke the entire thing and rebuild it from scratch. And it brings up all new servers, all scripted, all new AMIs, everything redeployed, totally fresh. So your options, and if you combine that with straight up services from Amazon like Elasticache or Cloud Search or the Lambda services, S3, their RDS database services, you start to even take the burden off things that you might have to maintain in a containerized environment, and you push those towards much more service orientated, rent by the minute style of environment, which is, again, incredibly effective, incredibly performant, automatically multi-AZ. You can scale them up to the wazoo if you need to. It starts to paint a picture of all of these things that were literally only within the purview of the largest possible engineering teams, now available to the smallest engineering team. And this is true even if you just have a single server sitting by itself. I like to do test deployments out to DigitalOcean. I use exactly the same containers that I run locally or run in Amazon. I just pop them out onto DigitalOcean droplets to see how they work and how they perform. And, we dream about, we could change DigitalOcean if, the whole of the AWS infrastructure collapsed here in Australia. Probably have other problems if that were the case, but there's that possibility that kind of floats through your mind that if you had to move, you could move, and you want to keep kind of testing those environments to make sure that you really do have the agility that you originally designed the systems to have. So I think I've simplified some things there in terms of the provisioning pipelines for things like how do you do your builds of your Docker images, how do you store Docker images in a registry, how do you maintain access to that registry. All of those things are they're solved problems. They're just work to be done that you would configure as part of your strategy for an implementation of a pipeline. There are still problems with Docker. There are still some major engineering issues that need to be solved. I think just simple things like file systems. Nothing's durable. If you've got a container that can fly out onto one server and then move to another server, be destroyed and redeployed, you need to think very carefully about the state of your application. If it writes a file locally and depends on it, then you need to have some additional tooling that allows you to replicate that file. Typically, we'd use a CDN like S3, but there are options. It just makes life more complicated. How do you do monitoring and logging? There are lots of solutions for this, and it's still kind of, shaking out. But you can rent a log drain, call them a log drain. You've got 20 containers, and they're all logging stuff, and it's all temporal. You need to be able to just pour that stuff down the drain somewhere so that it falls into a bucket that you can review later. The biggest issue for us, which is still a major engineering issue for Docker, is security of secrets. So things like your database username and password. It's very convenient to pass it in as an environment variable. And if it's very convenient...
But are you just doing environment variables for all those secrets? Because
Well, if it's convenient, you know people are going to do it.
Right.
So, I mean, it's true, and it's every API key you can imagine. All of those things, it's like a order of magnitude harder to do the right thing about securing them and encrypting them, and not somehow embedding them in your code base. So
and you have to really check for that.
You do. I mean, I think we mitigate that by having our own private registry, and Docker images that contain anything like that are not public. You can try and obfuscate them in some way. But if you write it into your code base and that API key has gone into your Git repo in any capacity, there's a potential leakage problem there. So, there's all kinds of additional things you can do to secure the boundary of your network and the ports that are available and all the stuff that this kind of classic infrastructure lockdown. But secrets is still a major, major problem in the Docker community. Is you've got all of this configuration by environment and no easily achievable way of securing and encrypting those keys. There are definitely mechanisms. There's the one we like the look of is HashiCorp's Vault, which you can deploy as a container, and it's
right. Yeah, we've been looking into that.
Yeah, and there are others actually. There's a really cool one that stores everything on S3 and uses Amazon's key generation service to automatically sign and deliver those encrypted secrets to your container at runtime. There are a lot of interesting areas here that are being developed, but it's one of those things that I think we really need to see some better direction from the Docker community itself. Docker Inc. And they're definitely working on it. There's no doubt about it. It's a major issue for everybody who's deploying stuff, is how you manage secrets. I don't think it's any different from the problems that people have today, frankly, sticking crap into their code bases that if anybody had access to the repo, would reveal all kinds of interesting secrets that shouldn't be revealed. But it's certainly something that you would hope they would clean up, fix, and then everybody could be secure for once. That'd be the dream.
Soon, Geoff. Soon.
It's coming. It is coming. As I say, the rate of change in the Docker community is astounding. Absolutely astounding. There's so many people making commits. It's just trying to keep that product roadmap in place because it's so volatile. Making sure everything's backward compatible and the new stuff keeps rolling out it must be a monumental engineering effort. Anyway, that's me.
Geoff, it's been truly enlightening to have you on the show. I want to thank you so much, and I realise that the time difference from Sydney to anywhere really is make these kind of things kind of a little bit difficult, but we really appreciate it. Thank you, Geoff. Thank you, Rob. And till next time.